1500, getting you ready to take this final exam, but we have one more concept to cover before we get into the study guide. So this video is going to include this new concept called residuals. Residuals play a very important role in regression. And then there will also be a study guide. So you're going to have this video, depending on how I break up the other videos, but maybe one or two more videos after that. But everything from here on out, after we study residuals, is focused, get you focused on preparing for the final exam. Okay, guys, a residual again plays a very important role in regression. It determines the appropriateness of the model that we use. We don't get into that as much here, but I tell you what, let's just learn the definition and let's just keep it simple for Math 1500. The definition of a residual for a data point is it's the observed y minus the predicted y. The observed y turns out to be the y that we actually collected when we were collecting our data. So the observed y for this first order pair, because you got to figure these points that are presented in this table can be looked at as ordered pairs. So the observed y is just the value of y in each ordered pair. So the observed y would be 1 here. The observed y in the second order pair is 4. The observed y in the third order pair is 3, and so on and so forth. Now, the best way to get an idea what a residual is to look at the graph. But again, let's go back up here to the definition. A residual is the observed y minus the predicted y. And remember, in the predicted y, what should you think? Where do we get the predicted y's? We get this from the regression model that we've talked about in previous videos. So to get the observed y, we go directly to the ordered pair, the data that has been collected. To get the predicted y, we have to create this model, put our x value in the model, and create what's called the predicted y. So sometimes up here, I'll put at the top, if you use notation, oftentimes you'll see residuals reported as y minus y hat. Why? Well, the y value is what we have in our ordered pair, x comma y. And our y hat is what we get from our model using our prediction. Using our x to make a prediction. All right, let's see how this plays out, and I think it'll make a lot more sense. First thing I want you to do is let's get a graph so we can examine the relationship between x and y. I don't have my calculator up. So first thing I would want to do is go into edit. I've got some data in there previously, so I'll go clear enter, get rid of those. Clear enter, get rid of those. And now I just want to type my x's and y's. So my x's were 0, 1, 2, 3, 4. No, they weren't. They were 0, 1, 2, 3. And my y values were 1, 4, 3, 8. Okay, now I want to graph those. So I'd go up second function, stat plot, make sure that my first plot is the only one that's on. Select the icon for the scatter plot. I've already got XList and YList set up correctly, so I'm going to go zoom 9 to get zoom stat. Now, what are the three things that we look for in a scatter plot? Do we have a linear relationship? I say yes. Do we have a positive or negative relationship? Clearly it's a positive relationship. And is it strong, weak, or moderate? Well, guys, I think this is strong. Now, we can better examine the relationship between x and y by fitting the linear regression model, the line of best fit, as we've called it before, to the graph. So the easiest way to do that is come over to Test, come to Linear Regression t-test, make sure we've got L1 and L2. That needs to be 1. Beta and rho doesn't matter at this point. Your Y1 needs to be there. I've shown you twice how to do that, so if you don't have that, you just haven't been watching the videos, so you need to go back and figure that one out. And hit calculate. Now guys, once you hit calculate, some really cool things happen. A lot of cool things happen. The first thing that happens is we can come down here and we can get our R and our R squared. And sure enough, our R turns out to be 0.88, which indicates a strong relationship. We also get the slope and the intercept of our regression model. This A and B gives us the slope and of our, well, I'm sorry, A is the intercept and B is the slope. So we know that our regression model is y hat equals 1 plus 2x. So I'm going to write that down. So our regression model is y hat equals 1 plus 2x. We don't have to do any work. We don't have to do any fancy schmancy formulas to get these values. They exist, but if you were taking one of my more advanced classes, we would look into that. But at this level class, we let technology find those values for us. And that gives us more opportunity to kind of figure out what these numbers mean. Okay, now a really cool thing about once you conduct your t-test on your calculator, if you'll just hit graph after having your scatter plot up, it will graph the regression model. Now, if you look at your regression model, let's talk about some tendencies and patterns that we see, or at least some observations, I should say. The line goes through one of the points. 2 of the points are above the line, and one of the points is below the line. Now, a residual is the difference between what we observe and what we predict. So let's go back over to where I can draw, and let's talk about that a little bit, okay? So I've got this model that was drawn like this, okay? Now I want to examine this point right here. Now this point had a particular x. So this point right here had a y value too, right? Well, I'm sorry, this is a y hat. This point right here had a y value. Okay, so this point x, this is what we observed and we plotted it. We plotted this point, we plotted this point, we plotted this point, and we plotted this point to create this. We can use this point, bring x up to the line, to predict the value of y for that particular point. Same thing over here. I've got an x value right here. Let's call this x1 and x2 so we know they're different. Well, this is what the point that we observed, but if I put this x2 into my line, into my formula here, y hat equals b0 plus b1x, then I get the predicted value. So guys, the difference here of the observed y and the predicted y is nothing more than the residual. And we can see that since our observed y would have a value that is less than our predicted y, then we would have a residual here that is negative. Compare that to this point right here. The observed y that we use to create the line, the predicted y that we get from inserting our x into the equation and finding out the value of y that would be predicted. Here we have a residual that is positive because the observed y, let me get my hand out of the way, the observed y is bigger than the predicted y. Okay? Now we're gonna work these out in numbers and not as much graphically as we go along. Okay? All right. So let's come down and let's think this out. We have our ordered pairs x and y's, again 0, 1, 1, 4, 2, 3, 3, 8, just like we did up here. Our observed y is just the y that we get from our ordered pairs. It is the data that we collected. It is the observed value. For example, I think we did something, we talked about an example in a previous video where X may be a midterm exam and Y may be a final exam. And let's say that a student scored an 80 on the midterm and a 90 on the final, then their observed final exam score was a 90. So we would have a 90 there. So anyway, observed is what we actually collect. Now the predicted value right here is going to be what we're going to get, the predicted value, when we put our X value in, when we put 0 in for our X value. So this first ordered pair has an X value of 0. We put that into our model. We see that we get a predicted value of 1. We're going to do that again for the second. Now we're going to do it when X is equal to 1. Next we'll do it when X is equal to 2. And then we'll do it again for X is equal to 3. All right? So in this case we have 1 plus, well, we have 2 plus 1 is 3. Our next order predicted value would be 1 plus 2 times 2, so we get 4 plus 1 is 5. And then we put 3 in our model, and we see that we get 6 plus 1 is 7. Guys, the residual is the observed y minus the predicted y. 1 minus 1 is 0. 4 minus 3 is positive 1. 3 minus 5 is negative 2. And 8 minus 7 is positive 1. Now we go back to our to our graph. Let's think about this 0, 1, negative 2, and 1. That was the residual for this point because the observed was equal to the predicted. This was plus 1 because the observed value was 1 unit above the predicted. This one was minus 2 because the observed value was 2 units below the predicted. And for this X value right here, we'll just call that X3. The observed value was 1 unit above the predicted, so its residual was plus 1. Now, an interesting feature of residuals is the sum of the residuals will always be equal to 0, and you can see that 1 plus 1 minus 2 gives us 0. Okay? So these things are really super easy to find. And even better than that, if you did everything on your calculator like I instructed you to, your calculator will find the residuals for you. So if we go to, let's get out of this and go back to a blank home screen. If we'll go second function list, somewhere down here, you may have to scroll down further. It just depends on the calculator and the operating system and what's been stored and blah, 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 and deleted. But you'll see that mine is residing at number 7. Yours may be at number 1. Yours may be at, number 9, whatever. But somewhere down there, you will see that you have a key called residuals. Now, I can take these residuals, and there's a really cool feature on your calculator right here that says store. If you look to at the 1 and the 4 and look just to the left, you see a button that I just hit called store. When you hit that, it's going to put a little arrow up there, and it will allow you to take whatever you have in front of the arrow and store it somewhere. Well, I think a reasonable place to store my residuals would be in L3. So I hit enter. Now you can see that it gives you a vector 0, 1, negative 2, 1 of your residuals that we created by hand. And if you go back to edit, you'll see that it will not only give you L1, L2, but it'll also give you L3. So the X value for the first observation was 0. The Y value for the first observation was 1. The residual for the first observation was 0. Second point, let's scroll on down to the fourth point. X value was 3, Y value was 4, residual was positive 1. Okay? So, guys, residuals again play an important role in this class because we're a little short on time. All we want to do is just be able to find those and know that they exist, be able to define those, and so on. Well, not even so on. That's it. Just be able to just understand they exist, how to calculate them, yada yada yada. Now, an exam question before I get into the study guide. An exam question that I almost always give is going to work something like this. Let's say that we can calculate someone's GPA. So we'll have a predicted GPA. And I'll tell you what, let me do something real quickly here. And let's have, because I'm trying to make something pertinent here. So just give me just a second. I'll be with you quickly. All right, let's say that we can predict someone's GPA by taking 0.32 plus 0.12 times someone's, not GPA, that's ridiculous, times their ACT. So what I've done is I've created a model that we can put your ACT in and predict your GPA. And let's say in creating this that we have someone that had an ACT equal to 19, and they had a GPA equal to 2.8. So let's consider that the GPA is the first year college GPA, and of course the ACT is the score you got on the comprehensive part, the overall part of your ACT. Now, what do we know here? We know that the observed ACT, which is our X, is equal to 19. We know that our observed GPA, which is Y, is equal to 2.8. And we know that we can get our predicted GPA, which is just indicated by a GPA with a hat on top of it, by taking our model plus 0.12 times our ACT score. So gang, what you can do here is you can take 0.32 plus 0.19 times the, it's 0.12 times 19. So the predicted GPA would be 2.6. What we can do now from this information right here is we could calculate the residual for that student by taking their observed Y minus their predicted Y. Their observed Y was 2.8. Their predicted Y was 2.6. So their residual was 0.2. So this student, based on their ACT, did a little better than what our model would have predicted them to do. In fact, they scored, their GPA was about 0.2 higher than our model predicted them. So we would consider that to be a success based on their ACT. Now we know in education that the best predictor of first year GPA isn't always ACT. In fact, sometimes it's definitely not. One of the smartest guys I know, a guy I went to high school with, he really did well in the ACT. I forget exactly what he got, but he was up there around 34, 35, and got a full ride, I think, to Murray State, which kind of surprised us all because we thought he was Ivy League bound, and he went to Murray State, and lasted about a month. Found out that college just wasn't for him, and he didn't go to college. But smart guy, really really smart guy. All right, gang. Let's get into the study guide part. So this example here is just going to focus solely on the correlation, regression, and residuals part. Okay. So let's get it going. So what we want to do is we want to measure the relationship or examine the relationship between anxiety level and test performance. So a psychologist obtains a random sample of 6 students, and 15 minutes before the exam, the psychology takes them to a lab and measured their heart rate, their GSR, whatever that may be, blood pressure, and so on and so forth, and puts all this together to come up with an anxiety score. Guys, a higher anxiety score means more anxiety. So this student right here, student number 3, had an anxiety rating of 7. I think the highest anxiety rating that you could get in this was a 10. So this student right here is pretty much flipping out. This student right here is pretty much flipping out. This student right here, chilling out just fine. No anxiety whatsoever, or at least not much. Only a 2. This is their exam score, 80, 88, 80, 79, and so on and so forth. So we want to see if there's a relationship between a student's anxiety rating and their exam score. Because a lot of times students will tell me, and I don't always believe it, but the students will tell me, Dr. Darber, I know the material, I just flip out when I take an exam. I think that's true sometimes. I truly believe anxiety does play a role in testing, but I think sometimes you can overcome anxiety by preparing effectively. Guys, I've been doing this a long time. I've been teaching now, started teaching in 1988, so I've been teaching now 27 years. I've given a lot of tests. I've taken a lot of tests. And I do believe there are certain people that just completely flip out when they take an examination. I think there are other people too that just don't prepare hard enough. So it's hard to know when there's a difference. All right, gang. Part A: prepare a scatter plot. How would you describe the shape of the scatter plot? So let's do that. So I'm going to use this calculator here. Just I want to get rid of all this stuff. All right, you know what? I think this is going to show up better if I use the other calculator. So I think I'm going to do that instead. Sorry. All right, so we got 527. Seven 4 5. Sounds like a phone number. Oh, messed up. All right. 80, 88, 80. And 79, 86. And 85. All right, guys, before I get into anything fancy, I want to take a look. I want to take a picture. Not take a picture, but create a picture. So second function, stat plot. Make sure it's turned on. Everything looks good. Zoom 9. What are the 3 things that I look for in a scatter plot? Is it linear? Yes. Positive or negative? Clearly negative. Strong, weak, or moderate? Well, I would call that strong. So I'm going to go back to my handout. How would you describe the shape? Linear? Negative? Strong. Find and interpret the R and R squared. Okay, so guys, I make it easy on you here. To find the R and R squared, we'll go to stat. We'll go over to test. We'll go to linear regression t-test. Everything looks good there. L1, L2, that doesn't matter. Make sure you got Y1 there, you should, and hit calculate. So we scroll all the way to the bottom, and we see that our R value is negative 0.89. And we see that our R squared is 0.79 or 79%. All right, so I've written that over here on the handout. The R equal negative 0.89 confirms what we thought up here from the picture. We have a strong negative relationship. I gave you the breakdown on a previous video, what determines what the cutoff points are. And the R squared tells us that 79% of the variance in exam score can be explained by the regression on anxiety rating. And again, I gave you that. I wrote it out in a previous video, so you have that in your notes, or you should have that in your notes. All right, gang. Next thing, report the test statistic and p-value for R. Is R statistically significant? Well, this takes a little bit of work, but you know, we've done multiple of these before. So the first thing we're going to do is always state our null and alternative hypothesis. So the parameter value for R is rho, and we always, at least in this class, conduct a two-tailed test when we're looking at the statistical significance of R. That's not going to change in this class. Next thing, we don't have a specified alpha value, but you know, I think it should be clear by now that if we don't have that, we use 0.05. The next thing we're going to do is we're going to create our test statistic. And as we know from previous videos, the formula for the test statistic is this right here. Now, we can do different things in our calculator, and I prefer to do this in my calculator using the values for R and R squared. So what I'm going to do here is I'm going to go back and work this with my calculator. Now, since I've got this worked out, my R and R squared is saved in my calculator according to the problem I just worked. So what I can do is I can go to my home screen, and I can go over here to variables, go to number 5, go over to equation, and come down to number 7. So I have my R. Now I want to divide that by the square root of 1 minus R squared. Got to go back to variables, go to number 5, go over to equation, and I'm pretty sure this is number 8. I'm going to take the chance that it is number 8, and it is. Now I want to close that up, and then I want to divide by my sample size minus 2. Well, guys, I had 6 students, so 6 minus 2 gives me 4. So this is the most effective way. Now I'm going to hit to the right, and so I think this is the most effective way to get the test statistic, because it doesn't round anything. If we had used, you know, -0.89 and 0.79, we would have some rounding issues. Okay, so I get a test statistic of negative 3.88. Now, so when I get negative 3.88, I am now set to find my p-value. And remember, the p-value, we're going to look at the distribution. So we're examining a distribution, t-distribution degrees of 4. Sorry, guys. So I'm going to take negative 3.88, look to the area to the left. And remember, I always have to look in a two-tailed test at the area to the right as well. Okay? So This is easy stuff. And I've had students before. They're like, well, Dr. Darber, I don't understand that. Why do you have to take it to the left of the negative and to the right of the positive? Well, you know what? At this stage of the game, preparing for your final, if you don't get that, you just got to accept it. You just got to tattoo it to the brain and say that's just the way the process works. In a two-tail test, we have to account for the area in two tails. Now, if we had a less than there, we'd just account for the area in the left tail. Or a greater than, we'd account for the area in the right tail. A two-tail test not equal to accounts for two tails. So we just do that. Now, we can find the area from negative infinity up to negative 3.88 or 3.88 up to positive infinity. And again, either way, we've got to multiply by 2. So I'm just going to find the one to the right because I don't like negative numbers. Maybe that comes from banking. I don't know. So guys, go to distribution, come down to TCDF, which is number 6. I'm going to take 3.88 up to infinity with degrees of freedom 4. I'm going to multiply that by 2. So my p-value is 0.0178. So the purpose of this problem is report the test statistic. Report the p-value. And answer the question, is R statistically significant? Yes. Gang, there is something going on with this anxiety level, anxiety rating, and predicting final exam score. So since now, let me get this a little clearer. It seems like it's a little fuzzy. All right, hopefully that helped. Since we have a yes there and R is statistically significant, it means that our model is appropriate for predicting exam score from anxiety rating. Okay, so we can use that. Now, find the estimate B0 and B1, actually B1 and B0. This is super easy. Got your calculator, use it. Well, wait a minute, I put the information in the other calculator. So let's go get that. So gang, the value that goes with the x is the slope. That's our B1. So in this case, that would be negative 1.78. And the estimate for B0, or the estimate B0, is what we have for our A, so that's 91.89. So what I have done over here is I've written those two values. So the estimate, B1 for the slope, this is the B from your calculator. And this is the A from the calculator. It could be, again, that could be 83, 84. TI-82s even work. Some of you are, tell me, well, I can't afford a calculator. Guys, you can buy like a TI-82 calculator for $15. You could have handled that. So, and some, I don't know, maybe you could. Maybe it's just one of those times where times are tough. But it's just the way I teach it. We could do all this stuff by hand. It would be insane. Then you got R. I mean, R is free, and I'll show you how to run R. Run this on R here in just a second. So write the regression model using the variables of the problem. Well, we are predicting exam score. So we put a caret or a hat above it. And we have 91.89 minus 1.89 times the anxiety rating. Keep in mind that this, let me write this down here at the bottom. Was that 91.89? For some reason, I'm second guessing myself on that. Yeah, it was. Okay. Keep in mind, this is the same thing. What's important is that this negative 1.89 goes with your x. And our x in this case is anxiety because, this is x, y. Okay. So it doesn't matter which is written first. It just matters that the slope goes with the variable that is our x. Okay. All right, gang. Interpret the slope. We've done this before. We would say as x, which is our anxiety rating, increases 1 unit. I'll tell you what, that's getting too cluttered. Let me. So the interpretation of our slope, we would say is x, which is our anxiety rating, increases 1 unit. Our predicted exam score decreases 1 point, what was it, guys? 1.89, is that what it was? Yeah. 1.89 points. So that's the interpretation of the slope. Now, predict the final exam score for a student with anxiety rating equal to 6. I would use my calculator here. I'd hit graph. I've got my line drawn now. I would go second function, go value, type in 6, and I'm done. So 81.22 is the exam score that we would predict for a student with an anxiety rating equal to 6, okay? Final question, calculate and interpret the residual for student number 1. Well, gang, what do we need for a residual? We need the student's X score. We need the student's Y score. We need their predicted score. And therefore we can calculate their residual. Well, for the first student at a 580, so they scored a 5 on the anxiety rating score and they scored an 80 on their final exam. The predicted value we're going to take our 5 and put it in our model. So I'm going to go back to the calculator and do that. So the predicted value for this student would be an 83. Which I wrote there, used them by my calculator. Now, if you don't like that, you can use your calculator. It was, what was that again, 91.89? And you'll see, wait a minute, what did I do here? I don't know why I can't remember this. 91.89 and 1.89. So 91.89 minus 1.89 times 5. All right, much better. So we get an 82.44. It's off a little bit because of rounding. That's why you use your calculator. Your calculator, when it does the predictions, noticed it used 91.88888888 a bunch of times, and then minus 1.77, and it went out quite a ways. So it doesn't round to two places, so it gets a better answer. So gang, your residual is the observed y minus the predicted y. So this student got a residual of -3, which says they scored 3 points lower than our model would have predicted. So again, their observed value was 3 points less than what we predicted, hence the -3. So their observed score was 3 points less than their predicted score. All right, guys, we are done. Let's check this out and see how we do these problems on R. Turns out really cool, and it works really slick and really fast. As always, it's always a little bit of a pain in the tail to type this into R, but I'm going to call the first anxiety. So I'm going to put 5, 2, 7, 7, 4, 5. And next I'm just going to call that exam. You can call it whatever you want. Remember, we have to use the C function. All I'm doing is very carefully typing in the 6 values. What I'll do now is I'll create my model, and the function that you use in R is called LM, linear model. I want my Y to come first, then I use my tilde. Guys, your tilde is way up in the upper left-hand part of your keyboard. It's to the left of the 1 key, and it's a second function. It's kind of a squiggly looking line, and I want that to be a function of my X. So guys, you have to put your Y first and then your X second, whatever you've named those. Guys, hit enter. Nothing will happen if you did it correctly. If anything went wrong, it'll give you a red warning or error or something like that. Now what you can do is you can just type model, and you'll see that you get your answer. Under the intercept, takes all the guesswork out of it, 91.889. The anxiety is your X, so this part right here will be your slope. Now you can get your residuals just by typing RESID, model, and you will see numbers that'll pop up for your residuals. Notice that our first student, we calculated by hand that this student had a residual of -3. And this shows that it confirms that. If you want to get a plot is really easy. Just do exam over anxiety. And you'll see you get your scatter plot as well. Correlation's easy to get. Just do a correlation between anxiety and exam. And if you want to get your R squared, you get this. So guys, really, everything can be done, right there. So one thing too, you can do summary of your model, and well, I thought it would give you your, yeah, it does right here. It'll give you your p-value. It won't give you your test statistic, but it'll give you your p-value of 0.0178. There's some way to get your test statistic too, but I don't. Let's see this. I think this will do it. No. Let me think this one through. Well, it's irrelevant. Actually, your I tell you what, if we take the square root, we get it. Yeah, the square root of the F statistic. So 1506. Take the square root of that, you get 3.88. The negative is something you just have to think through because your test statistic will always have the same sign as your R value and the slope of your regression model. So, guys, just a little bit of an FYI there. Most of you are going to do these problems using your calculator, so it's all good. Gang, I'm done. Have a good one.